Okay, in this section we're going to be looking at 2E and 2F. So these two sections are going to feature acceleration and then some more details on VT graphs. So the first thing is acceleration. So acceleration is how fast an object's velocity is changing. So it has a symbol A. It's how fast the object's velocity is changing. So we can think about that like if there's an object and it's rapidly speeding up or rapidly slowing down, we would say that it has a large acceleration. Right? Compare that to if we have an object that's more gradually or slowing down or speeding up more gradually, we would say it has a smaller acceleration. So again, acceleration is how that velocity is changing. Does that velocity change rapidly? Does that velocity change more gradually? So because acceleration is a change in velocity, remember velocity is two things. It's speed and direction. So if an object is accelerating, if its speed or direction is changing. So again, if either the speed of an object changes or the direction, that means its velocity is changing, and that means you have acceleration of some kind. So if it's changing the way it's going, if it's changing the rate at which it's moving, you have acceleration. The standard metric units for acceleration is going to be, this should say acceleration. So the standard units for acceleration are meters per second squared. So meters per second squared. And what that looks like is this: m dash s and then the squared above just the s. So really that's the unit. And that's really what that says is it's changing by how many meters per second every second. So how is that speed changing? Last thing to keep in mind about this is, what's the relationship to velocity and acceleration? What does that mean for the object if they're, depending on how they're, or what direction they're going in? So if we have an object that is speeding up, then the velocity and acceleration are in the same direction. So if we have an object that is moving, let's say this way, to the left, and then its acceleration is that way too, we would say that's speeding up, because not only is it moving one way, but the acceleration is going the same way, and that means the velocity is changing in that same direction, so it's going to tend to speed up. So the other thing is if we have an object that's slowing down, then its velocity and acceleration must be in opposite directions. So for example, let's say we have velocity in this to the left again, but let's say the acceleration's to the right in the other direction. So if you have something like this, if the velocity and the acceleration do not agree, what that means is the velocity is going one way, but the change in velocity or the acceleration is going to cause it to eventually slow down. So again, if they agree, the velocity and acceleration, then you'd say that's speeding up. If they're not in agreement, if they're opposite, that object's going to be slowing down. So those are all the basics for acceleration. So what it is, and then what it means to be speeding up and slowing down. Okay, let's see the next section. So this is going to be some just more details on VT graphs. So this is a VT graph. We're going to talk a little bit about it. If you have a section of the VT graph headed towards, so if you have a section of the VT graph that's headed towards the t-axis, that object's going to be slowing down. So let's say like right here, it's headed towards the t-axis. Right here, it's headed towards the t-axis. That object's going to be slowing down because if we remember, if you're on the t-axis, you're at the 0 mark for velocity. So again, as you get closer and closer to that, you're slowing down. So it's important to keep in mind. And the opposite's true too. If you have sections of a graph headed away from the t-axis, that means it's speeding up. So like right here, it's headed away from the t-axis. Right here, it's headed away from the t-axis. In either of these two places, it's getting further away from that 0 mark, and it's increasing. It's going either more positive or more negative. But either way, that velocity is getting to be a bigger number. It's speeding up. And the last thing, what does the slope mean on a VT graph? So if you see a line that's not flat and it has some non-zero slope, it's going to mean something. So the steeper that slope is, the faster the object is changing velocity and the greater the acceleration. So for example, we have this section right here is definitely moving, so there's definitely an acceleration right here. It's definitely changing its velocity, but it's pretty gradual. Let's compare that to over here, where there's a slope, but it's steeper. So they're both of these sections of graph, you see the velocity change, but in one part of the graph, it's more gradual, so that's going to have a lower acceleration, and over here, it's going to have a higher acceleration because it's steeper. So that's what the slope means on a VT. And the last thing, just kind of a note, you're going to see AT graphs every once in a while, but they're going to be fairly simple. So you're only going to see constant acceleration AT graphs or acceleration time graphs. They're going to look like this, where the acceleration's one value here, and then it's another value, and then another value, right? But all constant. So there'll only be flat lines on the AT graphs that you will see. There's not going to be curves. And there's not going to even be diagonal lines. So again, just a couple additions to velocity graphs, what they mean, some of the finer details. Okay, the last thing what we're going to do is we're going to look at a problem that involves some VT graph stuff and also acceleration. Here we go. So before I go through it, make sure you solve it out first. So again, make sure you're solving it out before I go through it. Okay, so I'll go through this. We have a squirrel that's running steady, or that's running east at a steady 5 meters a second. Right, that's the first thing. Then that squirrel slows down to pick up an acorn. Then the squirrel stands in place, admiring the acorn. So that's what's happening. So east at a steady speed, then slows down, then stands in place. So it's asking, the first thing is a VT graph. So there's 3 sections to the motion. And again, these are going to be all common VT shapes just kind of put together. So the first shape is going to be east at a steady 5 meters a second. That's going to look like, so a steady 5 meters a second on the VT graph, that's going to be a level line to show that the velocity is constant. So you're going to draw a level line up here. That's the first part of the motion. 1. Then it slows down to pick up an acorn. So if we remember, the middle part is 0. That's the 0 velocity. If we hit the t-axis, it's not moving. That's 0 velocity. So if it's slowing down, it's getting closer to that. So we're going to see a diagonal line down towards that axis. That's part 2. And then part 3, it says it stands in place admiring the acorn. So if it gets to standing in place, that means it got all the way to 0. Didn't just slow down. It slowed down all the way to a stop. And it's standing in place. So if standing in place, that means a 0 velocity. So it's going to be right on that axis, that t-axis. So that's the third part. So constant velocity, slowing down, stopped. So B is asking us something a little bit different. Is the acceleration positive, negative, or 0 for each part of the motion? Let's write this out. Part 1, Part 2, Part 3. What's happening? So for Part 1 of the motion, that's a constant velocity. So it's a constant speed, and that's going to mean if you have a constant velocity, there's no acceleration, there's zero acceleration. So acceleration is really only if you have a change in velocity. So if you have a flat line like that, it's going to be zero. The next part, 2, it starts out, right, it's at a positive velocity up here, and then it's going down towards that line. It's decreasing its velocity. So if you're changing your velocity at all in any way, that means you must have an acceleration. And in this case, you're positive and you're getting more towards the 0 mark. So you're positive, you're getting more towards the 0 mark. That must mean you have a negative acceleration. That velocity is changing in a negative way. Right? It's opposite to the positive velocity that you have. And then the last part, what's happening down here? 3, it's not moving. So if it's not moving, then it's not changing its velocity at all. It's just doing whatever it was doing. So we'd say that's a 0 acceleration, because if it's not moving, it can't be changing its velocity. So that's the problem. Again, remember there's 3 parts to this motion, and at each part we looked at what is the acceleration. And the only time it's important to remember, the only time you're gonna have acceleration is if you have a changing velocity, like what we had in 2, where it started at one point, it started at a positive and then got more and more negative as you went. So that's the problem. Those are the notes. Make sure you have the problem solution and the notes copied down, and that's it for now.